Greetings everyone, my name is Pratika Gupta, enrollment number 19122015. I am a third year student of BTech Engineering Physics and the topic of my video presentation for the course PHN 313 is data compression. So first of all, what is data compression? In minimal words, storing data such that it consumes less space. Data compression is a process of modifying or encoding data with less number of bits. That's why data compression is also known as bit rate reduction. So why we need data compression? As it is clear that nowadays the amount of data is increasing exponentially and so is the concern for storing it. So if we can store the same amount of data using less space, then it will reduce the consumption of resources such that hard disk space and transmission bandwidth. And also it is clear that transferring data with less size also consumes less time, so it will be also time saving. What kind of data can be compressed? Image, video, text, audio, speech, all of these can be compressed. Types of data compression. Data compression can be of two types. First one is lossless and second one is lossy. As the name suggests, the original data can be perfectly retrieved in lossless, while in the lossy, some data is lost. Both compression reduce the file size, but the lossy one compromises with the quality. But in the lossless, the quality is not lost. Algorithms used in lossless data compression are run length encoding, Huffman encoding, arithmetic encoding, etc. And while algorithms used in the lossy compression are transform encoding, discrete cosine transform, and fractal compression. Since the original data can be perfectly retrieved or reconstructed from the lossless compression, that's why it is also known as reversible compression. And while the lossy one is known as irreversible compression. Examples for lossless compression is zip file format and for lossy one is JPEG compression. Now the algorithms used, now some common algorithms used in data compression. First one is run length encoding. In run length encoding, rather than storing the same sequence of data, the data is stored as letters and counts. So if I want to store 3333 5 then rather than storing 3 4 times and 5 2 times, I can store 3 4 and 5 2. That is, the letter 3 is stored and the number of times that is 4 is stored. The second one is arithmetic encoding. In this, less number of bits are used to store data which occurs frequently. For example, apple. In this, p occurs twice, so p can be stored using 00 and 01 or 01, while ALE can be stored using 100 or 101. In this way, it uses less number of bits. Now, Huffman encoding. Huffman encoding is a bit similar to arithmetic encoding. It also uses frequency of the letter of or the number occurring. The transform is done via Huffman tree. The letters are arranged in the order of their maximum occurrence, then one with the minimum occurrence are merged, and the process continues till the words in the word is encoded. While the words are being merged, the top one is assigned 0 and the bottom one is assigned 1. In this way, 0s and 1 are assigned to the word, and the word is coded. Now from this slide, the algorithms are for lossy compression. First one is discrete cosine transform. This one is used for image compression and has a very strong energy compaction. Considering image to be in a spatial domain, using this we can store it in frequency domain. Very similar to discrete Fourier transform. Consider image to be in a matrix having values as pixel values. So the cosine matrix is pre-multiplied to get the transform, and then the matrix obtained is in the frequency domain. So generally more of the data is stored in low frequency component than in the high frequency component. So high frequency data can be discarded. That's why this one is a lossy compression. Fractal compression. Fractal compression is generally used for digital images that has texture or has natural images. In fractal compression, generally it is also used for images having self similarity. In this, image is first divided into m cross m images and then in 2m cross 2m images. Then a mapping is learned from m to 2m, one in terms of a self-repeating pattern. And through this learned map, the image can be decompressed again, and in the image can be decompressed again. So in fractal compression, the decompression or compression is learned via mathematical data called fractal codes. Now the transform encoding. In transform encoding, the knowledge of the application is used to choose the information to be discarded. So depending upon the application of the data, the image is divided into n cross n sub images. Then a transform is applied, which can be a DCT, DFT, or anything. Then the data is quantized, and with the help of the encoder, the image is compressed. Since there is quantization, so the minute details of the data is lost. That's why this one is also a lossy compression. So what can be the problems with the data compression? The data compression can be slower for large data or the sophisticated methods. In compression, if some error occurs, then there can be an unknown byte pixel relationship. So the data cannot be properly recovered while decompression. And also, since compression and decompression are also a process, so it also consumes computing resources. And if we transmit compressed data, and while the transmission error might occur, so while decompressing the data, the original data cannot be recovered fully. These are some software generally used for compressing: WinZip, WinRAR, 7-Zip, ZipArchiver, pzip. These are the references that I have used for this presentation. Thank you.